This is section 3.2, day 7. I'm going to do an example with the symmetric difference quotient. Here it is. Approximate the slope of the tangent line to y equals 3 root x minus 2x plus 1 at x equals 16. And we're going to use 3 different tolerance levels. So the symmetric difference quotient, we're going to use f of a plus h minus f of a minus h all over 2h. This is the formula. I like to include it on my paper so I can see what I'm doing. In order to do this, my a value is 16, and here's what I need: f of a plus h. If h is 0.1, I want f of 16.1 minus f of 16 minus 0.1, which is 15.9, all over 2 times my h value, 0.1. So I'm going to let my calculator do this work, and I'll show you a way that makes the calculator kind of easy to do on the calculator. First, type in the equation into y1, and then what I'm going to do is I'm going to just use function notation with the calculator to do this at the home screen. There are multiple ways to do this, but this is how I like to do it. So I'm going to alpha F4 to select y1, and I want it evaluated at 16.1. And now I'm going to subtract y1. I'm using alpha F4 at the function value 15.9. And there's my numerator. I actually need to get that answer and then divide by 0.2. So I'm going to go ahead and hit enter to get that answer. And there it is. I don't want to lose any decimal places. I don't want to round in the middle of the problem. So I'm just going to take that and divide by 0.2. And I get negative 1.624998169. I'm going to show you another way to do this using the fraction bar. Kind of makes it nicer. If you don't have the new operating system and you need to get the y1, you use variables, y variables, function, and you can select the one you need, so y1. And actually this function notation works for any value you wanted to evaluate the function at. So you could put in any value you want, calculate the function, hit enter, and you have it. So this is the technique I'm going to use. Alright, so let's make the tolerance even better. And we're making it a tighter tolerance, 0.01. So this time we're going to need f of 16.01 minus f of 15.99 all over 2 times 0.01. So this time I'm going to use the fraction bar. I'm still going to use my function notation here. So in the new operating system, alpha F1 gives you choices for a fraction bar. So I'm going to use that. Alpha F4, y1 of 16.01, close parentheses, minus alpha F4, y1 of 15.99. Close that, and I'm going to drop down to the denominator and just put in 0.02. Hit enter. And it looks like my answer changed just a little bit, negative 1.624999982. I'm showing all the decimals because I want to see the differences as my tolerance level changes. Okay? Alright, let's do it one more time for a tolerance of 0.001. So I have f of 16.001 minus f of 15.999 all over 2 times 0.001. Now this time, for my calculator, I'm just going to edit what I already have. So I'm going to move up to the line that I'm interested in, hit enter to basically copy that line, and then I'm going to move over to the left and edit it. So in the denominator I need an additional 0, So second insert a 0, move up to the top. I'm going to second insert a 9, move over to the left here. I'm going to second insert a 0. Hit enter. Oh, look at that. Negative 1.625. Terminating decimal. Maybe that's the answer. Anyway, we can see how the number changed, and basically as the tolerance gets smaller, your answer is going to get better and better. So this is actually the best answer. Here's the good news though. Your calculator has this function built in. So it's pretty nice. It's actually called the numerical derivative. Purely calculations without limits. And your calculator actually uses a tolerance of 0.001, just like we just did. Okay? Now, some notation issues. Your textbook uses the notation NDER for numerical derivative. And the format that it uses is it lists the function first, and then it lists the A value of interest. Your calculator, well, it depends on what operating system you have. In the new operating system, actually in either operating system, it's math number 8, and it's the function is I call it nderive, numerical derivative function. And if you have the new operating system, this is what's going to show up on your screen. You're going to get D, and then a place to make an entry here, and then it's going to have parentheses and a box for you to make an entry there, and a line and another place for an entry there. So let's see what all these places are. First of all, this hopefully you'd recognize as the notation for a derivative. You're going to put your variable here, and it's always going to be x. This is where you're going to put your function. And you can actually type in your function here, or you can reference y1 or y2 or whatever your function you're using from your y equals screen. And then this is where your x value goes, the x value of interest. So we'll put an A there. So this will calculate the numerical derivative of this function. So to do this for the function we're working at, we're going to put in ddx of y1 evaluated at x equals 16. And if we do that, let's do this real quick. We'll do math 8. Whoops. Math 8. Get to where you can see this. I'm going to put x there. Move over. I'm going to select y1 here. Remember, you could put the actual, you could type in the actual function there. And then at x equals 16, hit enter, and there you go. That's the numerical derivative answer at a tolerance of 0.001.